So we are in video 8 of RM and IPR, wherein we are will be covering module 2 with this 8th video. So in the last video we dealt with different types of descriptive research design and advantages and disadvantages of those, and also we had started causal experimental design, right? So here causal in the sense experimental research or causal research. So we also learned what exactly is that, and we'll be learning about the classification of experimental design or causal research design. So basically it is classified into 4 types, that is pre-experimental, true experimental, quasi-experimental and statistical experimental design. So what do you mean by this? Under pre-experimental, again you have one short case study, one group pre-test, post-test and static group, wherein under true experimental you have pre-test, post-test control group and post-test only control group, and again under quasi-experimental you have time series and multiple time series, and in statistical you have Latin square and factorial method. So before starting with the types, let us just have a brief of all the symbols which are being used for the formulas on different types. That is, X being the exposure of a group to an independent variable, a treatment or an event, the effects of which are to be determined. O is the process of observation or measurement of the dependent variable on the test units or group of units. R, capital R, is the random assignment of test units or groups to separate treatments. EG is experiment group, CG is control group, T is treatment effect, and R is randomization. So coming to the types. First is pre-experimental design. The basic thing is, in pre-experimental they do not employ randomization procedure to control the extraneous factors. And pre-experimental design is a type of research design which is used in social sciences and other fields to study cause and effect relationship between variables. It involves a single group of participants and subjects and lacks the strict control and randomization found in more robust experimental design. They are generally less rigorous, but it still provides variables inside and also finds a relationship between the variables. We have one short case study in that. So what do you mean by this? One short case study is, it is also known as after only design, and it is represented as X is equal to O2. That is, O is your observation, X is treatment. So here what happens is, a single group of test units or participants are exposed to an experimental treatment X and a single measurement or observation O, which is taken later. And then it only measures the post-test results and does not use a control group or pre-test. It is straightforward, but it lacks control over external factors. So there is no random assignment of test units in this. For example, an advertisement of Pear soap is being shown to the respondent, and then they were asked whether they can recall the ad or not. So this is about one short case study. One group pre-test, post-test designers, it is symbolized as observation 1, treatment, and observation 2. So in this design, a group of test units are measured twice. A single group of participants, here what happens is, a single group of participants are measured both before and after the intervention. There is no control group. First a pre-treatment measurement is taken, and then the group is exposed to the treatment. Finally a post-treatment measure. And probably you will get with the treatment effect as O2 minus O1. That is after treatment minus before treatment. For example, respondents are first interviewed to know their opinion towards consuming alcohol, and then advertisement depicting harmful effects of that is shown to the respondent. After watching the ad, the respondents are again being interviewed to test their opinion towards consuming alcohol. So you will be able to find the difference between after the ad and before the ad. So that is how you calculate pre-test and post-test design. Next is the static group design. So basically it is a two-group experimental design. One group being the experimental group, which is exposed to the treatment, and the other called the control group, which is not exposed to the. So here what happens is you have your control group and then the experiment group and treatment effect, so which is calculated as O2 minus O3, because for the experiment group we are giving the treatment, that is we are giving the procedure or process. And then let us move on to the advantages of pre-experimental design and limitations. See, for all the experimental designs we have advantages and disadvantages. Probably it helps you to cover up for more number of marks. So advantages are it is simple, cost effective, and it is feasible. So simple in the sense, see, it is you don't have much of the variables or much of the treatments, just you have one group wherein you need to go for pre-test or post-test, right? And it is cost effective. Yes, it is feasible. You can implement these designs wherever considering the ethical considerations. And then let us move on to the limitations of pre-experimental designs. First being the lack of control, and then internal validity, threats to validity, generalizability. Lack of control as pre-experimental designs lack the randomization and control found in more robust experimental designs, leading to potential biases and confounding variables. These designs are generally weaker in establishing causal relationships due to the absence of control groups and random assignment. We cannot generalize these designs. True experimental design. True experimental design is a research design that represents the gold standard for establishing cause and effect relationship between the variables. Again, here variables are dependent variables and independent variables. It is characterized by the random assignment of participants to different groups, manipulation of an independent variable, and careful control of extraneous variables. The goal of true experimental design is to minimize bias and confounding factors, ensuring high internal validity and allowing researchers to draw strong causal interference. In this again we have few factors like the existence of a control group, the presence of an independent variable, and random assignment. So here the sample of participants is subdivided into two groups, experiment and control group, and you also have an independent variable which works on the dependent variable, and then random assignment, right? Pre-test, post-test control group design. Test units are randomly assigned to either the experimental group, and control group will be just as a it's like it won't participate in the process or the treatment. And both the pre-test, that is before giving the experiment, after giving the treatment also we take, and then they calculate the differences between them to come out with the outcome or solution. This is an example for which we have shown for pre-test and post-test. So see, in order to measure the impact of tuition on the performance of students, first a sample of respondents would be selected at random. Half of these would be randomly assigned to the experimental group and the other half would form the control group. Respondents in both groups were given a test to check their performance. Only the respondents in the experimental group were given a tuition, and then both groups were given test and their performance was checked. And then next is post-test only control group design. Experimental group is exposed to the treatment but the control group is not, and no pre-test measurement is taken over here. So experimental group and control group you have, and you conduct a post-test only for control group, right, and no pre-test for the control group. Again, coming to the advantages and disadvantages of your true experimental design. They have high internal validity, replicability, and causality. High internal validity is true experimental design provides strong evidence of cause and effect relationships due to the rigorous control over confounding variables. Replicability, the random assignment and control over extraneous factors allow for replicating the study and obtaining consistent results. It allows researchers to confidently establish causal relationship between the independent and dependent variables. Next, coming to the limitations of the experimental design. Yes, coming to the limitations, they are expensive, practical and ethical constraints are there, artificiality and external validity. True experiments have high internal validity, so their findings may not always be generalized to the external environment apart from the internal factors. So that is one there. And it may not be feasible or ethical to randomly assign participants to different groups. And true experiments may sometimes be conducted in controlled laboratory settings which may not fully reflect real world situations. Yes, that is there. So coming to the third one, that is quasi-experimental design. A researcher can control when measurements are taken and on whom they are taken, but is unable to expose test units to the treatments randomly. So quasi-experimental research design is a type of design used when the random assignment of participants to different groups is not feasible or ethical. Unlike true experimental designs, which rely on randomization to establish cause and effect relationships, quasi-experimental designs use alternative methods to control extraneous variables and draw causal inferences. They are often employed in situations where true experiments are not possible or it cannot be practically implemented. So coming to this, we have time series design. So first one being the time series design. This time series design involve having only one sample but taking measurements of the dependent variable on 3 or more occasions, right? So it involves a series of periodic measurements on the dependent variable for a group of test units. The treatment is then administered by the researcher or it occurs naturally. After the treatment, periodic measurements are continued to determine the treatment effect, and you can also symbolize this as O1, O2, O3 or more than that, 4, 5, 6, and then you give the treatment from the point where it was started. Again you continue with post treatment. So minimum is 3, maximum any number you can have depending upon your data set, the vastness of your research. For example, a manufacturing company might measure its workers' productivity each for week for a year. In an interrupted time series design, a time series like this one is interrupted by a treatment. Like the treatment was the reduction of work shifts in a factory from 10 hours to 8 hours because productivity increased rather quickly after the shortening of the work shifts. And because it remained elevated for many months afterwards, the researcher concluded that the shortening of the shifts caused the increase in productivity. That is, they lessened the number of working hours, which increased the productivity of the employees. Next is multiple time series design. It is also a type of time series design that includes another group of test units to serve as a control group. It may be represented as, we have a experiment group and control group over here again. What are the advantages of quasi-experimental design? Feasibility, real-world context, ethical considerations. Quasi-experimental design are often more practical and feasible in situations where randomization is not possible. Yes, real-world context, since quasi-experiments often use naturally occurring groups or events, they are more representative of real-world conditions. And then randomization may not be ethical, making it a more suitable one. And also you have this limitations wherein there will be selection bias. Yes, because you are not assigning randomly, so there will be non-random assignment of participants and it will lead to selection bias where they may differ systematically for pre-existing variables, and also it lowers internal validity. Quasi-experiments have weaker control over confounding variables leading to lower internal validity, and making it more challenging to establish causal relationships. Next is statistical experimental design, also known as statistical design of experiments. It is a systematic approach which is used to plan, conduct, analyze, and optimize experiments to gather data and draw meaningful conclusions. The primary objective of statistical experimental design is to efficiently and effectively study the effects of one or more independent variables on one or more dependent variables. So here you have more than one independent variable. That is what your statistical design says. So first one being Latin square design. So this Latin square design is used where the researcher aims to control the variation in an experiment that is related to rows and columns in the field. But we have to make sure the independent variable is there, or it has to be placed in each row and each column without fail, or it is not to be repeated, because you have equal number of rows and columns and also treatment. So that is how your Latin square method works. So for example, to find out the influence of price on sales, you have this price as independent variable and sales as dependent variable. So what happens is you have you consider x1, x2, x3 as low, medium and high prices. Sales again are influenced by store size and type of packaging. So in the matrix, as you can see, 3 cross 3 matrix. Here, depending upon the store size and packaging and also the pricing, the sales of the product depends. So this is how you are depicting. See, in each row and each column there is x1, x2, x3. You have to make sure those independent variables are to be placed in each row and column without getting itself repeated. So the next being the factorial method. So what is factorial design? When researcher chooses multiple independent variables in a single study, it is called as factors, because they will be called as factors. So the sales of a product may be influenced by both the price level and the store size. So here you are depicting it, wherein you are making an assumption of the sales to be so much, assuming that P1, X1 are at the right place. Right. So this is how your factorial design depicts or tells. Next is the key differences between the two methods, that is exploratory as well as conclusive. See, we are done with the description and explanation of exploratory research design methods as well as conclusive design research methods with this 8th video of RM, right? So we are done with this second module with these 4 modules, 5, 6 and 7 and 8. So we'll just go through the differences, that is brief the differences of these two. The key difference between the two research methods is that exploratory research is used to gain a better understanding of a research problem, where conclusive research is used to arrive at a conclusion, decision or a result. Exploratory research is more unstructured and therefore offers more flexibility when compared to the conclusive design, that is more structured and rigid. Conclusive research relies more heavily on the use of quantitative data. Yes. Therefore uses a lot of statistical tests and advanced analytical techniques, allowing it to have a larger sample size. Exploratory research relies more on qualitative data. Some common qualitative approaches used in exploratory research are interviews, focus groups and case studies as well. So in these 2 slides you can find the differences between exploratory and conclusive, and in the successive slide the difference between exploratory, descriptive and causal. So you, depending upon the parameters or the factors, again you can make a difference of these. And again in the last slide I have just given the references, the links through which I have referred this. It might be the textbook link or some reference journals, publications and all. So I hope you came out with a better idea of what exactly is a research design process, its different types, how you need to go with the research design document, what all to be included in that, and comparing all the types of research design methods or research design processes, right? So we are done with this module 2, which dealt with research design. And this video 8 is coming to an end. So in the next video, that is 9th video, we'll be starting with the third module. Thank you.